Let's look now at example 2, where we're going to do the entire confidence interval. A sample of size 49 has a sample mean of 35 and a sample standard deviation of 14. Construct a 98% confidence interval for the population mean using this information and interpret its meaning. All right, so let's go ahead and do this. So first, let's notice there's a 98% confidence interval. Our first step is always to find z of alpha over 2. So, just like we did before in our prior example, we're going to subtract 98% as a decimal from 1. That gives us 0.02. And then we want to take 0.02 and divide it by 2, which gives us 0.01. Let's look that up by using the command equal norm.s.inv 0.01. And we get negative 2.326. All right, so negative 2.326. And of course, the positive will also be our z value. But our formula is x bar plus and minus our standard deviation. So really let me say z first, our z of alpha over 2 times our standard deviation s divided by the square root of our sample size n. Okay, so let's fill in x bar, our mean. If we went back to our information here, x bar, our mean, sample mean is 35. All right, so while we're here, standard deviation was 14. Okay, so we want 35 plus and minus our 2.326. And notice we don't need to put both the negative and the positive here because that's taken into account with this plus and minus, times our standard deviation, which was 14, and our sample size is 49. So we'll have 14 divided by the square root of 49, our sample size. All right, now, before we move on here, let's just remember our square root of 49 is 7. If we want to, we can go ahead and do the 14 divided by 7, but I'm just going to do the entire right side of this in my calculator all at once. So I am going to put in 2.326 times 14 divided by 7 into my calculator all at once. I'll have 35 plus and minus 4.652. Okay, now that we've gotten this far, there are two calculations we have to do. We have to do 35 minus 4.652 and 35 plus 4.652. Our confidence interval is an interval. So we want basically two numbers that are the range of our interval, the bottom number and the top number. So first, 35 minus 4.652, that gives me 30.348, and then 35 plus 4.652 gives me 39.652. So my confidence interval goes from 30.348, and since our original data was to the whole number, we will go one decimal place out, so 30.3 to 39.7 if we round that. Now, it's always important to write your confidence statement after you've come up with your confidence interval, and on your test it's going to ask for that confidence statement. So since we had a 98% confidence interval, we are 98% confident the true mean, that means our population mean, and in this particular instance, let's see, did it tell us what this mean was about? No, but we'll look at a very specific mean in our next example. So the true mean is between 30.3, and 39.7. All right, so we're guessing at the population mean, and we have 98% confidence that we've caught it in this interval. And you can think of a confidence interval in this manner. If I were trying to guess at the age of all of the students in my statistics class, I could make a guess of, oh, let's say I guess that the average age of the students in my class is 21. Okay, well, I wouldn't have a very good chance of getting that right. However, if I make an interval and I say, I believe that the average age of the students in my class is between 18 and 22, I would have a much better chance of actually capturing the true average of the students in my class. All right, so that's what we're doing with a confidence interval. This interval has a good chance of capturing what the true population mean is. And in this case, we can be 98% confident that we have captured that true mean by using the methods that we've come across here.